So if you recall from univariate data, we had a kind of a mnemonic device to describe or to help us remember how to describe a data, CUS, and it stood for center, unusual things, shape, and spread. Well, we have a new one for bivariate data like with scatter plots called DOFS. And DOFS stands for direction, outliers, form, and strength. Okay, so it's direction, outliers, form. Form really just means what kind of equation would fit, and strength means how well would that type of equation fit the data. Okay, so let's start, and I'm going to kind of talk through this. I'm not going to do a lot of writing. We're going to just talk. Okay, so this is my ridiculous scatter plot, and I know it's ridiculous, but let's talk about the shapes or the description here. Direction. Let's start with that. The direction is just, in this case, it's positive. We're trending positive. We call that an association. And that means more explanatory yields more response. The bigger the shoe size, the higher the score. Okay, and I know that's a ridiculous cause and effect, but that's the trend. So the direction would be positive. I'll come back to outliers. Form. Form means, as you look at the equation, what type of model, what type of equation or function would fit? Would it be linear or exponential or logarithmic or logistic or trigonometric? I look at this and I think a line would fit this pretty well. I think it's not moving in an exponential way. It's not leveling out like a logarithmic. It doesn't have kind of that limit like a logistic. So I think I would say this is a linear model. Now strength really means if you drew the line through it, how well does the line fit? And I look at this, I think this line, as ridiculous as the setup is, the line fits really, really well. We really don't have much variability from that line. So I would say it's a strong relationship. It's a strong linear relationship. Now, it would be nice to have some kind of quantitative way to measure strength, and that's coming. That's called correlation, and we'll be talking about that in the coming days. But at this point, we really can just say, that it's strong. Okay, let me go back to outliers. So outliers, we have talked through our univariate data as outliers mean one thing. They mean something a little bit different in bivariate data. And I want you to imagine that we had, some kid, really smart, good reader, who also happened to be a very tall student, came in, and they missed the day that they were tested. They came in and were tested later, and they tested way up here. Okay, big shoe size, tall, 6.5-foot kid with a really, really good reading score. And in kind of that old model of looking at outliers where you just say, well, a piece of data is far away from the rest, you might look at this and say, well, this looks like it's far away from the other pieces of data. But you need to go back and think about that line that we drew. That point, this big, tall kid that can read really well, the point fits that line. So I wouldn't consider it an outlier. Outliers no longer mean is it far away from the data. It means is it far away from the trend. Okay, so here would be an outlier. Let's say we had a short little kid that could read really well but had small shoes, and they were up here. Okay, that would be an outlier. Okay, so points that differ from that equation or that line that you put in, those are outliers. It doesn't mean it's just far away from the rest of the data. Okay, so again, I'm going to put, this would be your outlier right here. Okay, the top point way up top there by direction, that would not be. Now, I collected some data from my students about the time it took them to come to school, the miles and the time. So down here was miles, and up here was time. And I would look at this and I would say, well, the direction is positive, right? It's definitely going in a positive trend. The form, probably linear. A line would fit it. And I think if we drew a line through it, that line would be pretty strong. And in terms of outliers, I think this person right here is probably furthest away from the trend. And the reason is that student walked to school. So doesn't live very far away, but it took that student a while to get there because that student walked. Okay, so that's how we describe DOFs. So real quick, this is some data on Old Faithful. And you can see it's the eruption time for Old Faithful and then the time between eruptions. So the longer Old Faithful erupts, the longer it will be before the next time it erupts. So let's talk. Direction. Looks positive. I don't really see any outliers. I don't see any points that are too far away from that trend. Form, I think pretty linear. And strength, I think if you put a line through this, it would be pretty strong. Now, one thing to notice about this, it's kind of unusual, are these clusters, right? And within those clusters, if you just look, there's really not much pattern within the clusters at all. It's the fact that the clusters are shaped the way they are that makes it so linear and in a way so strong and tells us so clearly what the direction is. Let's look at some more. So here's another shoe size and test score, but this is mixed in just one class, so everyone is the same age. So the direction, I don't think there really is much of one. Looks like just a scattering of points. Outliers, nothing. There really isn't a pattern, so there aren't really any outliers. Form, I think the best you could do is to plot a line like this through the middle of the data, and that tells us something that we'll get to in the coming days. And the strength, well, it's obviously all spread out, so it's a weak form. Next, the rising cost of a stamp. So you see year and the rate. Direction, it's positive. I don't see any outliers. There's nothing where it suddenly spiked up for a year. Form, I think it looks pretty exponential. I don't think it's logistic. I don't think that it's going to level out. And strength, I think if you found an exponential equation, it would fit it very well. It would be very strong. All right, let's look at some more. So I wanted to really just highlight some things we talked about here. Association describes this direction, that positive means above yields above, or more yields more. Negative means more yields less, so a negative. So outliers, we already talked about. It's an outcome that differs from the pattern. We have one more type of point we can describe, and that's what's called an influential point, which can be an outlier. It can kind of hurt your pattern or hurt your form that you see, or it can help the pattern. So what you see here is my data that I had my students give me on how many miles they lived from school and how many minutes it took them to get there. And it's this plot right here, and we already talked about the fact that positive, maybe an outlier right here, that it was linear and it was pretty strong. So most students at my school live, within the town that the school is. So I had another teacher add a piece of data to this because this teacher lives a ways away. They live 27 miles away, and it takes them 38 minutes to get to school. So then I added that teacher into our class plot. And again, I just wanted to, remind you that when you draw your line through, this teacher isn't an outlier. They fit the pattern. They fit the equation we would put through our data points. They would be what's called an influential point, because really once you see it on this scale, this student that walks, they don't really look like much of an outlier anymore either, right? The points seem to be much more clustered in this view, and this really, really helps see that the further away you live, the longer it's going to take you. The most maybe obvious graph I can give you of an influential point looks like this. Imagine we had 4 points. Sorry, they got a little messy there on the top. Let's do that. We have those 4 points, okay? And there's not really any direction to it. They're just 4 points that are in a square. If I added a 5th point right here, now I think your eye would think, well, then the line goes like that. So this point, this added point, this would be what's called an influential point. It's one that really dictates our pattern and changes the whole way we look at the graph, or reinforces heavily, strongly, what we were looking at with the graph.